Wait, what's going on? It's 4th grade math! There are tons of 4th grade math lessons just ready to be delivered to you. I'm talking long multiplication, long division, fractions, decimals, and more. If you're new to 4th grade, you're in the middle of your year, or you're reviewing, this is the place to be. So buckle up and let's get started, beginning with long multiplication. Long multiplication. Long multiplication is how we multiply large numbers. But before we jump in, I want to give you the game plan, alright? First, we're going to review multiplication to make sure we're all on the same page. Then we'll learn how to multiply double-digit numbers times single-digit numbers, and finally, double-digit numbers times double-digit numbers. It's going to be epic, okay? Whoa, wait, hold up. I can't believe this. It's Clancy. I've heard of this guy. He loves buying cupcakes. I think he likes to share them with his friends. This bakery has a tasty 6-count cupcake box. I mean, they look delicious. Let's say he buys 2 boxes. 2 boxes. If there are 6 in a box and he buys 2 of them, that would be 6 times 2. The number 6, 2 times. 6 times 2 would be 12. Right, 12. 6 times 2 equals 12. 12 is the product. The product is the answer to a multiplication problem. That's multiplication. Multiplication is when you have a number a certain number of times. Now, another day, let's say they have a special box with 9 cupcakes. Clancy decides to buy just 1 box. 9 times 1. 9 cupcakes, 1 time. He's getting 1 box. How many cupcakes is he buying on this day? 9. 9 times 1 equals 9. 9 is the product. Clancy is getting 9 cupcakes this time because he's getting 1 9-cupcake box. Awesome. Now, the following week, the shop releases a special edition box with 3 cupcakes inside. Clancy thinks the box looks awesome. I mean, I do too. It's a cool looking box. He decides to buy 5 of these boxes. 3 cupcakes, 5 times. Whoa! 3 times 5. This is the same as 3 plus 3 plus 3 plus 3 plus 3. The number 3, 5 times. What is 3 times 5? Yeah, 15. 3 times 5 equals 15. On that day, he is buying 15 cupcakes. 15 is the product. Alright, that's multiplication. But what if we need to multiply larger numbers? Double-digit numbers. You see, Clancy is going to have a big party. That's right. And he's going to need a lot of cupcakes. Clancy decides to buy 4 dozen cupcakes. How many are in a dozen? 12. That's right. To find out how many cupcakes he's buying, we need to multiply 12 times 4 because he's buying 4 dozen cupcakes. 12 times 4. Let's write down 12 times 4. We put 12 on top and 4 below it, making sure everything is lined up by place value. The 2 and the 4 are both in the ones place, so they line up perfectly. The number 1 is in the tens place. Because this 1 is in the tens place, it represents 1 single 10, so it really means 10. First, we'll multiply the ones, so we'll multiply 2 times 4. What is 2 times 4? 8. Yes, we put the number 8 here under the ones because we were multiplying the ones place. Wonderful. First step down. Next, we move over here to the tens place. We're going to multiply across. 1 times 4. Because we're multiplying the 10 spot, this is really 110 times 4. What is 1 times 4? Yep, 4. It's the number 4 one time. So we'll write the number 4 here in the tens place because we were multiplying the tens. And that's it. We have our answer. 12 times 4 equals 48. Clancy is ordering 48 cupcakes. Wow! 48 is the product. Hey, great job solving that. All we had to do was multiply the ones and then multiply the tens. Now let's try a few more to get used to this process. Here we have 21 times 3. We have the 21 on the top and the 3 below it. It's lined up by place value. The 1 and the 3 are in the ones place. The number 2 is in the tens place. First, we multiply the ones. So we'll multiply 1 times 3. What is 1 times 3? Yeah, 3. We'll put the number 3 here under the ones because we were multiplying the ones place. Awesome. Now we need to multiply the tens place. We're going to multiply across. 2 times 3. Because we're multiplying the 10 spot, this is really 2 tens times 3. What is 2 times 3? You got it, 6. So we'll write the number 6 here in the tens place because we were multiplying the tens. And that's it. We have our answer. 21 times 3 equals 63. 63 is the product. Fantastic. Next, let's try 42 times 2. We have the 42 on the top and the 2 below it. It's lined up by place value. Both 2's are in the ones place. The number 4 is in the tens place. First, we multiply the ones, so we'll multiply 2 times 2. What is 2 times 2? Yep, 4. Yes! We put the number 4 here under the ones because we were multiplying the ones place. And now we need to multiply the tens place. We're going to multiply across. 4 times 2. What is 4 times 2? 8. Tremendous job! So we'll write the number 8 here in the tens place because we were multiplying the tens. And that's it. 42 times 2 equals 84. 84 is the product. Let's do another one, but with a special twist. 57 times 2. We make sure it's lined up by place value and we're ready to go. First, we multiply the ones. What is 7 times 2? 14. Great. But 14 is a double-digit answer. What do? Well, we write the 4 down here in the ones place and put the 1, which is a 10, up here at the tens place. That's called regrouping. Regrouping. The 4 in 14 stays down here like we've been doing, and the 1 is carried up here. Then we multiply the tens. We do that by multiplying across 5 times 2. What is 5 times 2? 10. That's right. But we have this extra 10 that we carried over from 14 when we regrouped. All we do is add that extra 1 to the 10, which gives us 11. We write 11 down here, and we have our final answer. 57 times 2 equals 114. 114 is the product. Hey, let's practice regrouping with one more problem, and then we'll be ready to take things to the next level. How about 47 times 3? We make sure everything is lined up by place value, and we're ready to go. First, of course, we multiply the ones. What is 7 times 3? 21. Awesome! But 21 is another double-digit answer, but that's okay. This part is fun. We write the 1 down here in the ones place and put the 2, which represents 20, up here at the tens place. That's called regrouping. The 1 in 21 stays down here, and the 2 is carried up here with the tens. Then we multiply the tens. 4 times 3. What is 4 times 3? 12, yes, but we have this number 2 that we carried over from 21 when we regrouped. All we do is add that 2 to the tens answer we got. That gives us 14, because 12 plus 2 equals 14. We write 14 down here, and we have our final answer. 47 times 3 equals 141. 141 is the product. You are doing an amazing job. Now you know everything you need to multiply 2 double-digit numbers. We'll take it one step at a time, and you'll see it's not as tricky as it looks. Let's start with 21 times 11. We write 21 on top and 11 right below it, lining it up by place value. And we're ready to go. Now, for the first steps, we aren't going to use this digit down here in the tens place. We'll need it later, but we'll have to wait. What I like to do is cover it up real quick. Let's hide it behind this owl. Why an owl? I don't know. I guess I just really like owls, you know? Now we do the same thing we did before. First, we multiply the ones. What is 1 times 1? 1. Yes, 1. We'll put the 1 down here below the ones. Next, we multiply the tens. To multiply the tens, we need to multiply across. 2 times 1. What's 2 times 1? 2. 2. So we put the number 2 down here below the tens. Great. At this point, we are ready for the digit behind the owl. We have to move this owl. Since we no longer need this digit in the ones place, we can just scoot the owl over here. Before we keep multiplying, we have one more thing to do. We need to put a 0 in the ones place right here as a placeholder. Since this 1 that we just uncovered is in the tens place, that means it's really 10. That's why we put a 0 here. What's next? Well, we multiply like we did before, except we are multiplying by this digit in the tens place. We multiply across 1 times 1. What is 1 times 1? 1. That's right, 1. We put the number 1 right here. And what is 2 times 1? 2. Yep, 2. We put the number 2 down here. We're almost done. Now all we have to do is add these answers together. We just have to add them up. 1 plus 0 equals 1, 2 plus 1 equals 3, yeah. And this final line just has the number 2. And we have our answer. 21 times 11 equals 231. 231 is the product. Amazing job. Oh, cool. The owl is chilling in a tree. I mean, this isn't the same owl from our multiplication problem. First of all, this owl looks different, and our multiplication owl is a cartoon, so there's that. Maybe they're cousins. Let's try another one. How about 62 times 20? We write the 62 on top and 20 right below it, lining it up by place value. And we're ready to go. Remember, for the first steps, we aren't going to use this digit down here in the tens place. We'll need it later, but we'll have to wait. Let's cover it up real quick with the owl again, all right? After covering that up, we multiply the ones. What is 2 times 0? 0. Yes. If you multiply any number times 0, the answer is 0. We'll put the 0 down here below the ones. Next, we multiply the tens. What is 6 times 0? 0 again. So we put another 0 down here below the tens. Awesome. At this point, we are ready for the digit behind the owl. Since we no longer need this digit in the ones place, we'll just scoot the owl over here like we did last time. Before we keep multiplying, we have one more thing to do. We need to put a 0 in the ones place right here as a placeholder. Since this 2 that we just uncovered is in the tens place, that means it's really 20. That's why we put a 0 here. Now we multiply like we did before, except we are multiplying by this digit in the tens place. We multiply across 2 times 2. What is 2 times 2? 4. That's right, 4. We put the number 4 right here. And what is 6 times 2? 12. Yep, 12. We put the number 12 down here. Awesome. We're almost done. All we have to do is add these answers together. Since the top row is just zeros, we can bring down the other numbers without changing them, because nothing is being added to them. We now have our final answer, 1,240. 62 times 20 equals 1,240. 1,240 is the product. Fantastic! You've done an incredible job learning about long multiplication. Long multiplication is how we multiply large numbers. Let's do one more example, going through it one step at a time, except with this last one, we will use regrouping, okay? The last one we'll do is 34 times 13. We write the 34 on top and 13 right below it, lining it up by place value. And we are ready to go. Remember, for the first steps, we aren't going to use this digit down here in the tens place. We'll need it later, but we'll have to wait. Let's cover it up real quick with the owl again. First, we multiply the ones. What is 4 times 3? 12. Awesome. Now 12 is a double-digit answer, so we will need to regroup. Do you remember how this works? We write the 2 down here in the ones place. And where do we put the 1? Yeah, up here. This 1 represents 10. That's why it goes up here in the tens place. That's called regrouping. The 2 in 12 stays down here, and the 1 is carried up here with the tens. Then we multiply the tens. 3 times 3. What is 3 times 3? 9. Yes, but we have this number 1 that we carried over from 12 when we regrouped. All we do is add that 1 to the tens answer we got. That gives us 10, because 9 plus 1 equals 10. We write 10 down here below the tens. Great. Now that we are done using it, we can remove this number 1 that we regrouped, because we are ready for the next step. What do we do next? Yeah, you know what? We've got to move the owl. We'll just scoot the owl over here like we've been doing. When you do this, you can use your finger to block it instead of this owl. Not everyone has a fancy cartoon owl to block digits with, okay? Now we have one more thing to do before we continue multiplying. We need to put a 0 in the ones place right here as a placeholder. Since this 1 that we just uncovered is in the tens place, that means it's really 10. That's why we put a 0 here. And now we multiply. We are multiplying by this digit in the tens place. We multiply across 4 times 1. What is 4 times 1? 4. That's right, 4. We put the number 4 right here. And what is 3 times 1? 3. Yep, 3. We put the number 3 down here. We're almost done. Now all we have to do is add these answers together. 2 plus 0 equals 2. 0 plus 4 equals 4, yeah. And 1 plus 3 equals 4. That's right. And we have our answer. 442. 34 times 13 equals 442. 442 is the product. Amazing. Great job. Remember, when we multiply double-digit numbers by double-digit numbers, we cover this digit here and multiply the ones and then the tens. Then we cover the digit here in the ones place. Don't forget the placeholder 0. Then multiply by this digit in the tens place, starting with the ones and then the tens. Finally, just add these answers together, and that's it. Now you know how to multiply large numbers. You did an amazing job practicing long multiplication today. Keep practicing and soon you'll be able to solve even bigger long multiplication problems because I know you have what it takes. You did great with long multiplication. Well done. All right, now we're going to change it up. Next, we'll be learning about long division. That's right, long division. First, we'll do a quick division review to make sure we all understand how division works, and then it will be long division time. Long division is a really awesome way to divide larger numbers. We'll start with pretty simple examples and step it up from there. By the end, you'll know how to do all sorts of long division problems and will be ready to practice on your own. Now, what is division? Well, division is when you split a number up by a certain number. Let's say there are 4 pairs. Michael and Liam want to split the pairs, and they want to make sure it's fair. There are 4 pairs, and we're dividing the pairs into 2 groups, one for Michael and one for Liam. 4 divided by 2. What is 4 divided by 2? Yeah, 2. 4 divided by 2 equals 2. Michael and Liam both get 2 pairs. Tasty. 4 divided by 2 equals 2. This 4, the total number of pairs, is called the dividend. The dividend is the total number you are splitting up. This number 2 is the divisor. The divisor. The divisor is the number of groups you are splitting the dividend into. In this case, it's 2, because Michael and Liam are splitting the 4 pairs. And of course, this number 2 is the answer. The answer to a division problem is called the quotient. The quotient. This number 2 is the quotient. That's division. Division is when you split a number up by a certain number. Or say someone picks 9 apples and wants to split them up equally into 3 baskets. 9 divided by 3. What is 9 divided by 3? 3. 9 divided by 3 equals 3. There would be 3 apples in each basket. 9 divided by 3 equals 3. This number 9, the total number of apples, is called the dividend. The dividend is the total number you are splitting up. This number 3 is the divisor. The divisor is the number of groups you are splitting the dividend into. The divisor is 3 because the 9 apples are being split up into 3 baskets. And this 3 is the quotient. The quotient is the answer to a division problem. You know what? Let's look at just one more division review problem. There are 20 star stickers, and 5 kids want to split them up evenly so everyone has the same amount. 20 divided by 5. What is 20 divided by 5? Yes, 4. 20 divided by 5 equals 4. Each kid would get 4 star stickers. 20 divided by 5 equals 4. 20 is the dividend. It's the total amount of star stickers you're splitting up. The number 5 is the divisor. The divisor is the number of groups you are splitting the dividend into. The divisor is 5 because the 20 star stickers are being evenly split up between 5 kids. And this 4 is the quotient. The quotient is the answer to a division problem. Each kid gets 4 star stickers. Alright, that was our quick division review. Now it's time to take things to the next level. We're going to learn how to divide larger numbers using long division. We'll start really simple and build up from there. It's going to be fun. First, we're going to look at 48 divided by 4. 48 divided by 4. When we do long division, we use this thing right here. It's called the long division bracket. Oh, that's a long name. The long division bracket. This is how we set up a long division problem. We put the dividend, that's the big number we're splitting up, inside the bracket right here. The dividend in this problem is 48. The divisor, which is 4 in this problem, goes right here, right in front of the bracket. It's always set up this way. The dividend goes inside the long division bracket, and the divisor is placed out in front. That's a pretty cool setup. Hey, let's set up 48 divided by 4 again. We start off with the long division bracket. We put the dividend, which is 48, inside the bracket. Then we put the divisor, which is 4, right in front of the bracket, and we're ready to go. We're going to start with the first digit inside the bracket, the 4 in 48. We are going to divide. How many times does 4 go into 4? Yeah, 1 time. So we write a number 1 on top of the bracket right above this 4. Next, we're going to do something interesting. We're actually going to multiply this number 1 times the divisor. What is 1 times 4? 4, yes. We put that answer, the number 4, right here, underneath the 4 in 48. So far, so good. Then we subtract these 2 digits right here. What is 4 minus 4? 0. That's right. So we put a 0 here. Since we have this extra digit, the number 8, we'll bring it down. Do you see this 0 here? You don't have to worry about it. Even though it looks like 08, that's the same as 8. The 0 doesn't change the number. We're just working with the 8. Then we repeat the whole process again, except we divide this digit here, the number 8. We're going to divide again. How many times does 4 go into 8? 2. Yeah. So we put the number 2 on top of the bracket, next to the 1, and right above the 8. Next, we multiply again. This number 2 times 4. What is 2 times 4? 8. We put that answer, the number 8, right here under this 8. Then we subtract. 8 minus 8 equals 0. Yeah. And there's nothing left to bring down, so we're done. And we have our answer, the quotient. The answer to this division problem is up here above the bracket. It's 12. 48 divided by 4 equals 12. That might seem like a lot of steps to remember, but there's a trick to learn them. To do long division, all we have to do is divide, multiply, subtract, bring down, divide, multiply, subtract, bring down. First, divide. 4 goes into 4 1 time. Second, multiply. 1 times 4 equals 4. Third, subtract. 4 minus 4 equals 0. Fourth, bring down. Bring down the 8. Then we repeat the steps with this digit here. Divide. 4 goes into 8 2 times. Multiply. 2 times 4 equals 8. Subtract. 8 minus 8 equals 0. And there's nothing else to bring down, so we're all done. The quotient, the answer to the problem, is 12. The 4 steps in long division are divide, multiply, subtract, bring down. Let's try another one, okay? How about 93 divided by 3? That would be fun. Let's set up 93 divided by 3. We start with the long division bracket. We put the dividend, which is 93, inside the bracket. That's the big number we're splitting up. Then we put the divisor, which is 3, right in front of the bracket. The divisor is the number of groups we're splitting the dividend into. All right, we're ready to go. Remember, the first step is to divide. We're going to start with the first digit inside the bracket, the 9 in 93. How many times does 3 go into 9? Yeah, 3 times. So we write a number 3 on top of the bracket right above this 9. Next, multiply. We multiply this number 3 times the divisor. What is 3 times 3? 9. Yes, we put that answer, the number 9, right here underneath the 9 in 93. Great. Next, subtract. We are going to subtract these 2 digits right here. What is 9 minus 9? 0. That's right. Since we have this extra digit in the dividend, it's time to bring down. We'll bring down the number 3. That's awesome! Okay, now it's time to go through the steps again with this digit here, this number 3. Divide! How many times does 3 go into 3? 1 time, yeah. So we put the number 1 right here on top of the bracket. Next, we multiply again. This number 1 times 3. What is 1 times 3? 3, We put that answer, the number 3, right here under this 3. Then we subtract. 3 minus 3 equals 0. Yeah. And there's nothing left to bring down, so we're done. Well, we have our answer, the quotient. The answer to this division problem is up here above the bracket. It's 31. 93 divided by 3 equals 31. To do long division, all we have to do is divide, multiply, subtract, bring down. Wow, cute guinea pig. What if this guinea pig was listening and can now do long division? Nah, maybe. All right, let's try another one. But this time, something a little different is going to happen. Let's see what happens when we try 74 divided by 6. Will it split up evenly, or will there be something left over? Let's find out. Here's the setup. We have the dividend, 74, inside the long division bracket, and the number 6, which is the divisor, is right in front of the bracket. We're ready to go. Remember, the first step is to divide. We're going to start with the first digit inside the bracket, the 7 in 74. How many times does 6 go into 7? Yeah, 1 time. So we write a number 1 right here on top of the bracket. Next, multiply. We multiply this number 1 times the divisor. What is 1 times 6? 6. Yes, we put that answer, the number 6, right here underneath the 7 in 74. Fantastic. Next, subtract. We are going to subtract these 2 digits right here. What is 7 minus 6? 1. That's right, we'll put a 1 here. Now, since we have this extra digit in the dividend, it's time to bring down. We'll bring down the number 4. Awesome. Okay, time to go through the steps again with this number down here, 14. Divide. How many times does 6 go into 14? 2 times. Yeah. So we put the number 2 right here on top of the bracket. Next, we multiply again. This number 2 times 6. What is 2 times 6? 12. We put that answer, the number 12, right here under this 14. Then we subtract. 14 minus 12 equals 2. Yeah, and there's nothing left to bring down, so we're all done with the steps. Notice, instead of a 0 down here like we've been seeing, there's a number 2. This is called a remainder. a remainder. 74 can't be evenly split up into 6 groups. There are 2 left over. 2 is the remainder. We write R2 up here because there is a remainder of 2. That's pretty nifty. And we have our answer, don't we? The quotient is 12 with a remainder of 2. 74 divided by 6 equals 12 with a remainder of 2. Amazing job. All right, we're going to look at one last long division problem. In this final example, we're going even bigger. Okay, even bigger. We're going to divide a triple digit number. Okay, let's do 126 divided by 5. 126 divided by 5. Okay, here's the setup. We have the dividend 126 inside the long division bracket, and the number 5, which is the divisor, is right in front of the bracket. We're ready to go. Remember, the first step is to divide. We start by looking at the first digit inside the bracket, the 1 in 126. How many times does 5 go into 1? Wait, it doesn't. 5 is too big to fit into 1, even one time. So what do? Well, when the divisor doesn't fit into the first digit, we look at the first 2 digits together. That means we try the number 12. That's pretty cool. All right, how many times does 5 go into 12? Yes, 2 times. So we write the number 2 up here, right above the second digit in the dividend, the 2 in 126. Then we multiply. We multiply this number 2 times the divisor. What is 2 times 5? 10. Yes. We put that answer, the number 10, right here underneath the 12 in 126. Awesome. Next, subtract. What is 12 minus 10? 2. That's right. We'll put the number 2 right here. Great. Since we have this extra digit in the dividend, it's time to bring down. We'll bring down the number 6. This number down here is now 26. Very cool. All right, time to go through the steps again with this number down here, 26. So we divide. How many times does 5 go into 26? How many times does 5 go into 26? 5 times. So we put the number 5 right here on top of the bracket above the 6 in the dividend. Next, we multiply again. This number 5 times the divisor, also the number 5. What is 5 times 5? 25. Yes, we put that answer, the number 25, right here under this 26. Then we subtract. 26 minus 25 equals 1. Yeah, and there's nothing left to bring down, so we're all done with the steps. We have a remainder again, don't we? Instead of a 0 down here, there's a 1. This is called a remainder. 126 can't be evenly split into 5 groups. There's 1 left over. 1 is the remainder. We write R1 up here because there is a remainder of 1. And we have our answer. The quotient is 25 with a remainder of 1. 126 divided by 5 equals 25 with a remainder of 1. Aw, here's the guinea pig again. The 4 steps in long division are divide, multiply, subtract, bring down. When we start, we always try to divide the first digit of the dividend. But if the divisor doesn't fit, like in our last example, we look at the first 2 digits instead. And sometimes when we finish dividing, there's a number left over. That's called a remainder. We write the remainder up here next to the quotient with the letter R to show that the dividend didn't divide evenly. And that's how long division works. You did an amazing job practicing. Keep it up, and soon long division will be as easy as pie, as easy as apple pie. You know what? That looks yummy. That looks very delicious. Wow, that's impressive. You've been learning for a while, so feel free and stretch. Yeah. Maybe we can watch this beaver for a moment. Don't be scared. It's just a beaver, okay? A beaver doing beaver things. That's it. It's just a beaver, okay? All right. I think we're ready to learn more math, okay? Now we're going to learn about something related to division, fractions. Yeah, fractions. I love fractions because they make me think of pizza. Yeah, pizza. You see, a fraction is a way to show a part of a whole. And a whole pizza is usually way too big for one person to eat alone. People usually eat just a part or a fraction of a pizza. I'll show you how it works with this pizza here. The pizza is cut into 4 equal slices. That means the whole pizza is now in 4 parts. If I eat 1 slice, that means I ate 1 out of 4 slices. That's written like this: 1/4. 1/4. I ate 1/4 of the pizza. The top number shows how many pieces I ate, just 1. And the bottom number shows how many pieces the whole pizza was cut into, 4. 1/4 is a fraction. A fraction is a way to show a part of a whole. Let's look at 1/4 again. The top number, this number 1, is called the numerator. The numerator shows how many parts you have. The bottom number, the number 4 in this case, is called the denominator. The denominator shows how many equal parts the whole is split into. And this line actually means division. The numerator is being divided by the denominator. That's a fraction. Let's look at another one. This is a fraction you might have seen before. It's called 1/2. What if I had a smaller pizza and I decided to split it right down the middle to share with a friend? It's only cut into 2 equal slices or parts. If I eat one of those slices, I've eaten 1 out of 2, which is 1/2. This top number, the 1, is the numerator. It tells us how many slices I ate. This bottom number, the 2, is the denominator. It tells us how many equal parts the whole was cut into. Uh-oh, looks like someone wants the other half. Sorry, buddy, I already promised it to someone else. Plus, pizza isn't for dogs. Yeah, maybe we can find you some dog treats, you know? What are you gonna do, right, Mr. Whiskers? Yeah, we should probably go back to talking about fractions. Okay, check this one out. This time, I'm cutting the pizza into 3 equal slices. If I eat 1 slice, that's 1 out of 3. That's called 1/3. 1/3. The top number, the numerator, is 1, because I ate 1 slice. The bottom number, the denominator, is 3, because the whole pizza was cut into 3 equal parts. I ate 1/3 of the pizza. You know what? I've had a lot of pizza here, all right? And I get it, okay? But may I please just get a carrot, okay? I need carrots. Please, carrots. Okay, I feel better. Now, you know how the top number in a fraction is called the numerator and the bottom number is called the denominator? Well, I have a trick to remember that. When I think of fractions, I think of North Dakota. You know, the state. North Dakota. ND. It helps me remember that the numerator is on top And the denominator is on the bottom, North Dakota. I hope you don't mind. You've helped me through the years with fractions. Thank you, North Dakota. The numerator is on top. The denominator is at the bottom. North Dakota, ND. That's pretty cool, you know? Okay. Now that we've seen how fractions work, it's time for a game. I'm going to show you some shapes. Each one will have 2 different colors. Your job is to figure out what fraction of the shape is red, okay? Look closely at each shape, count the parts, and try to say the fraction out loud before I show you the answer. Are you ready? All right, we'll start with a simple one. What fraction of this triangle is red? What fraction of this triangle is red? Yeah, 1/2. Half of the triangle is red. Great. The numerator shows us how many parts are red. Just one part is red. The denominator shows us how many total parts the triangle is split into. The triangle is split into 2 equal parts. Awesome job. Okay, what fraction of this square is red? Remember to count how many pieces are red, and then how many total pieces there are. What fraction of this square is red? 3/4. 3/4 of the square is red. Tremendous! The numerator shows us how many of the parts are red. 3 of the parts are red. The denominator shows us how many total parts the square is split into. The square is split into 4 equal parts. It's split into fourths. 3 out of 4 parts are red. That means 3/4 of the square is red. Very cool. You're getting the hang of this. Fractions. Whoa, that's a big piece. That's going to make someone very happy. Oh, it's not as big now. Okay. Well, that makes sense. That makes sense. It's just not as big of a fraction as I thought it was going to be. You know what? Let's check out another one. What fraction of this circle is red? What fraction of this circle is red? Yes, 2/3. 2/3 of the circle is red. Fantastic! The numerator shows us how many of the parts are red. 2 of the parts are red. And the denominator shows us how many total parts the circle is split into. The circle is split into 3 equal parts. 2 out of 3 parts are red. That means 2/3 of the circle is red. Great job. You know what? We only have 2 more. Isn't that great, ducks? Where are you going? You're swimming away? You're not even going to give them a try? Wow, I don't know. I thought you could practice fractions too. Well, maybe next time. Okay, here's the next one. What fraction of this rectangle is red? What fraction of this rectangle is red? Yes, 4/5. 4/5 of the rectangle is red. Awesome! The numerator shows us how many of the parts are red. 4 of the pieces are red. The denominator shows us how many total parts the rectangle is split into. The rectangle is split into 5 equal parts. 4 out of 5 parts are red. That means 4/5 of the rectangle is red. Wonderful job. All right, here is the last one. I know you've got this. What fraction of this circle is red? What fraction of this circle is red? Yes, 3/8. 3/8 of the circle is red. Very cool. The numerator shows us how many of the parts are red. 3 of the parts are red. The denominator shows us how many total parts the circle is split into. The circle is split into 8 equal parts. 3 out of 8 parts are red. That means 3/8 of the circle is red. You did an amazing job learning about fractions. A fraction is a way to show a part of a whole. The top number of a fraction is called the numerator. The numerator shows how many parts you have. The bottom number of a fraction is called the denominator. The denominator shows how many equal parts the whole is split into. And this line actually means division. The numerator is being divided by the denominator. That's a fraction. And now you've got some good fraction practice under your belt. Keep up the great work. You'll be a fractions master in no time. All right, fractions. That was fun. No, I really don't feel like looking at this beaver anymore. I just don't. I'd rather just get into the next lesson. Okay, come on. This is 4th grade math here, right? Okay, we're going to continue to learn about parts of a whole by talking about decimals next. That's right, decimals. Do you know what these are? Yeah, bouncy balls. I love bouncy balls, I do. Uh-oh, the bouncy balls are coming into the hallway, and they can't even read this wet floor sign. Oh, wow, the bouncy balls are coming down the stairs? Oh my goodness, they're taking over the building! They're taking over the building! Oh, Mr. Whiskers, am I glad to see you? That must have been a dream. But bouncy balls are really cool, and they don't cost much. In fact, a lot of times you can buy a bouncy ball for less than $1, okay? What a deal! Let's say you're in a toy store and you see that bouncy balls cost 50 cents each. This is what it looks like when you write out 50 cents. Here's the dollar sign. You know, we're talking about money in this example, right? There's a 0 next to the dollar sign because it isn't even a full dollar. It's less than $1, so it has a 0 here. Then we have something called a decimal point. A decimal point. Then there's a 5 and a 0 because it costs 50 cents. This is a great example of something called decimals. Decimals! We're going to learn a lot about decimals in this video. First, I'll show you some decimals so you know what they look like. 0.5, 1.3, 0.25, 4.5. What do all of these decimals have? Yeah, they all have this point called a decimal point, just like we had when we wrote out 50 cents. Decimals have this point called a decimal point. When you see that point, you know you're dealing with a decimal. And that's awesome, because decimals are super cool. They're able to show us numbers that aren't whole numbers. Let's imagine you have one donut, okay? Exactly one donut. We don't have to use a decimal point. 1 is a whole number. You have one donut. But let's say someone gives you another half. Wow, you don't have just one donut anymore. You have more than that, right? You have 1.5 donuts. If you write that as a decimal, you have 1.5 donuts. 1.5 is the same as 1.5. 1.5. You have one full donut, then you received another half, 0.5. You have 1.5 donuts. I have one donut. If I stare at it long enough, maybe another half will appear, and then I will have 1.5 donuts. Check this out. Here we have part of a lemon, half of one to be exact. That means we have 0.5 lemons. 0.5 is the same as 1/2. Wow, apples! Apples are great! Look at all of these apples! Let's say we have this many apples, and we want to show how many we have without using fractions, okay? Because this is the decimal video, right? We're going to use decimals. First, how many whole apples do we have? Yeah, 2. That's right. But we don't have exactly 2 apples, right? There's this other half. It's time to use decimals. Let's put the decimal point next to the 2 because we aren't done. We still have this half here. In total, we have 2.5 apples. That's right. 2.5 apples. Because with decimals, 0.5 is the same as 1/2. We have 2.5 apples. That's the power of decimals, kids. The power of decimals. Oh my goodness, look at all of these coins falling on a table. You know, coins are a great way to practice decimals. Do you know what type of coin this is? Yep, a dime. That's right, a dime. Now, how much is a dime worth? 10 cents. A dime is worth 10 cents. This is how we write 10 cents. We have the dollar sign because we're talking about money. Then we write 0.10. 10 cents. A dime is less than a dollar, which is why we have the 0 here. When you just have a dime, you don't have a full dollar yet. In fact, you would need 10 dimes to have a dollar. 10 of them. A dime is 1/10 of a dollar. 0.1 is the same as 1/10, and as we learned earlier, 0.5 is the same as 1/2. Oh wow, this man is taking his dog shopping. Fido, would you like this? No? Okay. Would you like this bone? No? You know, Fido, this is kind of what they have. They have a lot of options. We might be here for the rest of the decimal video. While he looks for dog food, notice when we talk about cents, we have this extra 0 here, okay? 10 cents and 50 cents both have these extra zeros. But 0.10 and 0.1 have the same value, just like 0.50 and 0.5 have the same value. We just include that extra 0 because we are showing 10 cents here and 50 cents here. Okay, so this circle shows us 0.5, or 1/2. This circle shows us 0.1, or 1/10. It's evenly split into 10 parts, and only one part is colored in. 0.1. Check this out. We're about to play with decimals and circles. Mr. Whiskers, I'm singing again. I'm singing songs again. All right, let's get started. What decimal does this show? There are 10 equal parts, and just one is colored in. Yeah, 0.1. Terrific. Wait, a second part is colored in now. What decimal do you think this shows? 0.2. That's right, 0.2. Okay, whoa, we're going higher. How about now? What decimal does this show? 0.3. You're getting the hang of this. 0.3. Great job. You know what? Let's go ahead and color another part. What is this decimal? 0.4. Very cool. 0.4. Awesome. We've almost colored in half of this circle. Almost. Now, if we color in just one more part, what is this decimal? 0.5. Yes! Which is the same as 1/2. Half of this circle is now the color red. 0.5. Well done. Wait. Stop the music. It's this dog's birthday. I was thinking of stopping after 0.5, but in honor of this dog, this little doggie's birthday, I feel like we should keep going. I don't even know what this dog's name is. Maybe it's Cheese Nugget, who knows? And Fido is still looking for food. But in honor of Cheese Nugget's birthday, or whatever this dog's name is, let's keep going. Are you ready? So this is 0.5. It's exactly 1/2. 0.5. If we color in one more tenth, what is this decimal? 0.6. Nice. 0.6. Whoosh! Another part was just colored in. What decimal does this show? 0.7. You got it. 0.7. We're just 3/10 away from having a full red circle. Okay, another one has been colored in. What decimal is this? 0.8. Right, 0.8. That means we are just 2/10 away from a full red circle. Let's go ahead and color in another tenth. What is this decimal? 0.9. Terrific job. 0.9. We are so close to a full circle. We are just 1/10 away. I think we're ready. All right, I think we're ready. Let's fill it in. What do we have? 1. We have one full red circle. Amazing job. Real quick, I want to check in on Fido. How is the shopping? Still looking? That's cool. Let's go ahead and learn decimals with another coin. Do you know what type of coin this is? Yeah, a quarter. Do you know how much a quarter is worth? 25 cents. Fantastic. 25 cents. This is how we write 25 cents. We have the dollar sign because we're talking about money. Then we write 0.25. That's 25 cents. Now, do you know how many quarters you need to have a full dollar? Yeah, you need 4 quarters to have a dollar. A quarter is 1/4 of a dollar. 0.25. 0.25 is the same as 1/4. Alright, so 0.25 is 1/4. This blue part is 1/4 of the circle, 0.25. But if we double that, that's 1/2. What is the decimal for 1/2? Do you remember? 0.5. That's right. 0.5 is 1/2. Hey, it's raining quarters. Quarters are falling from the sky or from somewhere. That gives me an idea. Let's find out how much money you would have if you picked up some of these quarters. If you picked up just 1 quarter, how many cents would you have? 25 cents. Yep, 25 cents. Since we're dealing with money, we have this dollar sign, and 25 cents is written as 0.25, which remember is the same as 1/4 because 25 cents is 1/4 of a dollar. If you picked up a second quarter, you would have 50 cents. Awesome job. 50 cents. With 50 cents, we have the dollar sign, of course, and 50 cents is written as 0.50, which is the same as 1/2. 50 cents is half of a dollar. Okay, if you picked up 3 quarters, how many cents would you have? 3 quarters. 75 cents. Yeah, you would have 75 cents. When you write 75 cents, you include the dollar sign in the front and write 0.75, which is the same as 3/4, because 75 cents is 3/4 of a dollar. Finally, what if you picked up 4 quarters? How much money would you have? $1. A full dollar. $1 can be written like this, Or like this, with a decimal point and 2 zeros, showing there are no extra cents. Both of these are ways to write $1. We've learned a lot about decimals in this video. Decimals are awesome. They're able to show us numbers that aren't whole numbers. Like here, we don't have a whole number of oranges. We have 1½ oranges. What is 1½ in decimals? 1.5. Exactly. We have 1.5 oranges. We learned that 0.1 is 1/10. Here is 0.1, 0.2, 0.3, 0.4, 0.5, which is the same as 1/2, 0.6, 0.7, 0.8, 0.9, and then 1! One complete circle! And finally, we learned that 1/4 is 0.25. Using decimals, how many pizzas do we have here? 2.25. 2.25. We have 2 whole pizzas and then an extra 1/4 of a pizza. But 3/4 of this pizza is missing. Do you remember what the decimal for 3/4 is? 0.75. That's right, 0.75. I'm impressed. You did great. Those are decimals. Very cool. Now we're about to get into the next topic. I want to introduce the topic by asking you a question. This question. Hey, have you ever heard of positive and negative numbers? Numbers can be positive or negative. That's what we're going to learn about. What makes a positive number positive, and what makes a negative number negative? And what are some real-life examples of positive and negative numbers? Hold tight, we're going to explore all of these questions and more, starting with this. Do you know what this is called? Yeah, it's called a number line. A number line. Which makes sense, it's a line and it has numbers on it, right? A number line is almost like a map of numbers. Numbers always go from least to greatest on a number line. On this number line, what number is in the middle? Yeah, 0. The number 0 is in the middle of this number line. Since number lines move from the least to the greatest number, every number gets bigger as we move down the line. So 1 is bigger than 0, which we know. If you have 1 pancake, that's more than if you have no pancakes, right? I mean, no pancakes, that would be so sad. 1 is greater or bigger than 0. 2 is bigger than 1. 3 is bigger than 2. 4 is bigger than 3. You get the idea. Now, if we move the opposite direction on the number line, every number gets smaller. Yeah. Now, here's something interesting. 0 is not the smallest number. Numbers can go lower than 0. I mean, 0 is in the middle of this number line, which means all of these numbers are less than 0. Numbers that are less than 0 are called negative numbers. Negative numbers, that's what they are. Now, you might have noticed each of these negative numbers has a negative symbol right in front. That's true for all negative numbers, so they're really easy to spot. So numbers that are less than 0 are called negative numbers, which makes sense. They have this negative sign in front of them. Numbers that are greater than 0 are called positive numbers. Positive numbers. They are easy to spot too. Just look for numbers that don't have a negative sign in front of them. So numbers that are less than 0 are called negative numbers, which makes sense. They have this negative sign in front of them. Numbers that are greater than 0 are called positive numbers. Yeah, positive numbers. They are easy to spot too. Just look for numbers that don't have a negative sign in front of them. Let's talk a little bit more about positive numbers. Positive numbers are very common, very common. We see them everywhere. So much so that the main way we write positive numbers is just to write the number all by itself. You can put a positive sign in front of a positive number if you'd like, but you don't have to. Most of the time, it's just the number. Positive numbers, negative numbers. Pretty simple. Wait, what about 0? Is 0 positive, negative, or neither? Well, neither. 0 is actually the only number that isn't positive or negative. It's kind of in the middle of all of them in its own category. 0. It isn't positive or negative. It's, 0. Hey, we use positive numbers a lot, right? We see them all around us, but when do we use negative numbers? Numbers that are less than 0. Check this out. This is footage from Antarctica, the 5th largest continent in the world. What do you think the temperatures are like there? Yeah, super cold. At the South Pole, which is in Antarctica, the temperature can be as low as negative 100 degrees Fahrenheit in the winter. Negative 100 degrees. Wow. If you live in an area that gets really cold temperatures, maybe you've experienced how cold it is when the temperature reaches negative degrees, negative numbers. Wow, numbers so low, they dip below 0. Me, I live in South Carolina, so yeah, the temperature is always in positive numbers here. I don't know what negative temperatures feel like. I can only imagine. Another example of negative numbers is when we look at the elevation of different places on Earth. The elevation of a place is its distance above or below sea level. Now, what's sea level? Well, sea level is how we measure how high or elevated a place is compared to the average height of the surface of the Earth's oceans. Now, if a place is lower than sea level, its elevation is a negative number. For example, a place called the Dead Sea is at negative 1,407 feet. Negative 1,407 feet. In North America, there's a place called Badwater Basin. Badwater Basin. If you are at Badwater Basin, you are at negative 282 feet. That means you are 282 feet below sea level. Of course, elevations can be positive numbers, and most places on land are above sea level. Where I live, I'm at 39 feet, meaning I'm 39 feet above sea level. If you're curious about what the elevation is where you live, you can ask a parent or teacher. It's kind of fun to find out. All right, the last example of negative numbers is if you owe someone money. Debt or money that's owed uses negative numbers. For money you get, you would use positive numbers. Okay, you know what? It's time to review. Numbers below 0 are called... negative numbers. Great job. Numbers above 0 are called... Got it. Positive numbers. Awesome. And 0, is it positive, negative, or neither? Do you remember? It's neither. 0 is its own thing. Wow, you really know your stuff. Well, that's what positive and negative numbers are. Keep a lookout for them, especially those negative numbers. They are more rare to spot in the wild. Whoa, you did an awesome job learning about positive and negative numbers. We just have 2 more topics to go. You're moving right along here. Okay, the next thing we are going to learn about comes from the world of geometry. We're going to learn about lines, line segments, and rays. and then we can all clap, in celebration. I mean, look how happy this guy is, and he knows all about lines, line segments, and rays. Right, Bill? Right? Okay, he's doing his own thing. In math, a line looks like this. You have a line with 2 arrows, one on each end. These arrows show that the line keeps going on forever in both directions. A line has 2 arrows. Now, a line segment is so different. It has these 2 dots, one on each end. These dots are endpoints. It doesn't keep going and going. It starts at one point and then ends at another. This is a line segment. So here's a line. We know it's a line because it has these 2 arrows. Pretty cool. The arrows show the line keeps going and going in both directions, right? And what's this called? Do you remember? Yeah, a line segment. It has these 2 dots. They are endpoints. A line segment doesn't go on and on. It has these 2 endpoints. There's a beginning and an end with a line segment, isn't there? Now, what about a ray? What does a ray look like? Well, a ray is kind of a combo, a combination of the 2. You can see it right here. A ray has an arrow on one end, making it like a line on that side, but a ray has a dot on the other side, an endpoint, like a line segment. A ray has an endpoint and an arrow. A ray is a combo, right? It has both. Alright, so a line has 2 arrows. It goes on and on in 2 different directions. A line segment has 2 endpoints. It doesn't go on and on like a line does. It stops at the endpoints. It's pretty cool. And a ray has an arrow on one side and an endpoint at the other. That means a ray goes on in one direction, and then the other side just has that endpoint. A ray has both an arrow and an endpoint. Hey, I think it's time. It's time to unlock and discover a super trick. Something used by the true masters and legends of math. A trick you can use to discover if you are looking at a line segment, or a ray. Even this guy uses the trick. In fact, I think he may be writing me a letter right now. Dear Homeschool Pop, thanks for helping me with my math, and for buying me these candles for my birthday. Okay, here's the trick. Just count the arrows and endpoints to see if you are looking at a line segment, or a ray. You might have picked up on that already. See, we already know that a line has 2 arrows, a line segment has 2 endpoints, and a ray has 1 arrow and 1 endpoint. So we count the arrows and endpoints to discover what we're looking at. That's pretty simple. Just count the arrows and endpoints to see if you are looking at a line segment, or a ray. That's the trick. You've been doing an amazing job learning. I think you're ready for a very special game of Tell Homeschool Pop What You See. Whatever you see on the screen, just tell me. That's it. That's the game, okay? Let's start with this one. What do you see? Yeah, a flamingo. Yes, this is a flamingo. Great. All right, I know, you were probably expecting something different, something related to this video. The thing about this game is you don't know what you will see next. Let's keep going, okay? All right, what do you see here? What is this? Yeah, a line segment. Fantastic. How do we know it's a line segment? It has 2 endpoints. 2 endpoints. This is definitely a line segment. Great job. Okay, what do you see here? What is this? A ray. Awesome. A ray. How do we know it's a ray? Yeah, it has an endpoint and an arrow. Very cool. Here is our last one. What do you see here? What is this? You've got it. A line. Sweet. How do we know it's a line? It has 2 arrows. That's right. It has 2 arrows. This is a line. Wow. I must say, I'm impressed. You did such a great job. You know what? I'm going to say it. I'm going to say it. You know all about lines, line segments, and rays. You learned so much. You learned this is a line. It has 2 arrows, right? A line segment doesn't have arrows, but has endpoints instead. And a ray has 1 arrow and 1 endpoint. That's it. Wow, this is a cute bunny. Speaking of cute, I better go feed Mr. Whiskers. Yeah, I better. Mr. Whiskers! Mr. Whiskers! Very cool. Great job with that. And oh my goodness, there's just one more topic left in this massive 4th grade math video. Are you ready? Okay. Now, you are about to learn about something that's pretty cool called probability. 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 Probability is the chance of something happening. That's pretty simple. Probability is the chance of something happening. I'll show you how it works using coins. Yeah, coins are fun. Especially to spin, okay? Look at this spinning penny, and it might look like the penny's alone. Don't worry, the penny has coin friends. Let's say you have these 5 coins, 3 pennies, 1 dime, and 1 nickel. You decide to randomly pick a coin to spin on a table. This is going to be a totally random pick. You aren't going to peek. If you randomly pick one of these coins, how likely are you to pick a penny? That's a good question. Well, more than half of these coins are pennies, so the answer is likely. You will likely pick a penny. Likely means there's a big chance. Okay, how likely are you to pick a dime? Well, that's different. There's only 1 dime. Only 1 out of the 5 coins is a dime. How likely are you to pick a dime? The answer is unlikely. Unlikely meaning there's a chance, but you probably won't. You are unlikely to pick a dime. Well, let's not leave out the nickel. How likely are you to pick a nickel? Well, let's think about it. There's just 1 nickel out of 5 coins, just like we had with the dime, which means there's a chance you might pick the nickel, but you are unlikely to pick it. The answer is unlikely. You are unlikely to pick a nickel. All right, here's another situation. Say you are at a baseball game and you found some pennies. 4 pennies, in fact. Just to be silly, you decide to randomly pick a coin in your pocket to see which kind you pick, even though all 4 coins are pennies. How likely are you to pick a penny? Well, you have to pick a penny, right? Because that's the only option. You are certain to pick a penny. The answer is certain. In probability, we use the word certain to mean there's no chance of anything else happening. You are certain to pick a penny, 100%. Now let's look at a completely different scenario. Say I want a green balloon because green is my favorite color in the whole world, which it actually is. I don't know why, it just is. Green has always been my favorite color. All right, so I go to a store to try to buy a green balloon, but I don't know they only have red and blue balloons. All the other balloons are sold out. How likely am I to buy a green balloon at this store? Well, there aren't any green balloons, so there is no chance. It is impossible to buy a green balloon from this store on that day. Impossible is the word used in probability when there is no chance of that outcome happening. I can't buy a green balloon from this store right now. It's impossible. I'm just kidding. It might be impossible to buy a green balloon from this store today, but there's no way I'm giving up. I can go somewhere else and look for a green balloon, or come back here another day once they get more green balloons in. Alright, so probability is the chance of something happening. There are words we use to describe the probability of an event. There's certain, that means you have a 100% chance. It will happen for sure. There's likely, that means you have a big chance. There's a big chance it will happen. Then there's unlikely. That means there's a little chance of it happening. And lastly, the term impossible, meaning zero chance. Just like there was zero chance of me getting a green balloon at the store that day, that does not mean it will always be impossible. In fact, the probability or chance of something happening can change. Maybe you find another coin at the baseball game, a nickel this time. Or maybe a delivery truck arrives and suddenly I do have a chance of getting a green balloon at that store. Okay, now it's time for a probability quiz. I need your help. Pretend you are at a movie theater. You've been picking up coins you found along the way, 7 in all. 4 nickels, 2 dimes, and 1 penny. While you wait for the movie to start, you pick coins randomly without looking. How likely are you to pick a nickel? How likely are you to pick a nickel? Likely. Correct. You are likely to pick a nickel. More than half of the coins are nickels. You have a big chance of picking a nickel. That means it is likely. You are doing great. All right, how likely are you to pick a penny? A penny. How likely are you to pick a penny? Unlikely. You are unlikely to pick a penny. There's a chance you could pick a penny, but it's just a little chance. Unlikely. What's next? Oh, how likely are you to pick a dime? A dime. How likely are you to pick a dime? Unlikely. Yep, you are unlikely to pick a dime. With only 2 of the 7 coins being dimes, there's only a small chance you'll pick a dime. Unlikely. Okay, here's the final question. How likely are you to pick a quarter? A quarter? How likely are you to pick a quarter? It's impossible, yes. If you only have these 7 coins, it's impossible to pick a quarter because none of them are quarters. It's impossible. But remember, if you find a quarter later on, add that to your collection and play the same game, the probability would change. It wouldn't be impossible anymore, but it would be unlikely. So, probability is the chance of something happening. There are words we use to describe the probability of an event. There's certain, that means you have a 100% chance. It will happen for sure. There's likely, that means you have a big chance. There's a big chance it will happen. Then there's unlikely, that means there's a little chance of it happening. And lastly, the term impossible, meaning zero chance. Just like there was zero chance of me getting a green balloon at the store that day. That does not mean it will always be impossible. In fact, the probability or chance of something happening can sometimes change. You did such a wonderful job learning about probability, the chance of something happening. I think Mr. Whiskers is likely to agree. No, he's certain to agree. 100%. 100%. Mr. Whiskers. Wow, what a strange way to end that lesson. But you know what? That's it for this video. You just learned a ton of 4th grade math. Congratulations. Well done. In celebration, here's the beaver from earlier. I don't know. I can't give you a high five, so here's the beaver instead. You know your stuff. You know a lot of 4th grade math. It's great. It's great. Okay. Hey, thanks for watching this video all the way to the end. Way to go! If you haven't subscribed to my channel and you had a great time, be sure to click that subscribe button for more learning. I have a lot of videos. I want to thank my patrons for making videos like this possible. It means the world to me. And thank you for watching. You are awesome, seriously. And hey, I'll see you next video.